Hey guys, Mr. Bullock here. This Algebra 2 lesson is about 3 or 4 lessons from your Algebra 1 class combined. Let's go ahead and get started with this here. From your Algebra 1 class, remember this from your Algebra 1 class, x to the m times x to the n. You add those exponents. Powers raised to powers, you multiply them. So x to the m to the n is I multiply those exponents. You remember that from Algebra 1. All right, and if you have two numbers inside of parentheses being multiplied, being raised to a power, then it's each one of those numbers to the power being multiplied. So x to the m times x to the n. It does not work if there's a plus sign or a minus sign in there, only when there's a multiplication sign in there, or a division sign actually. Anything to the 0 power equals 1. I used to have an Algebra 2 book, you guys. Pretend like there's a big parenthesis right here and there's another big parenthesis right there. This Algebra 2 book put a big old polynomial expression in here with lots of math inside of there, really confusing. And up there they just put a little 0 power right there. It just canceled out everything. It was always 1. Anything to the 0 power equals 1. Alright, so a fraction, x to the m over x to the n, as long as these bases are the same, x's, then you just subtract those exponents, m minus n. Alright, and when you have a fraction to an exponent, then it's the numerator to the exponent over the denominator to the exponent. Okay, we're going to be using all of these coming up. Okay, if you have negative fractions, okay, you just put it in the denominator, it becomes a positive fraction. And if it's in the denominator and it's a negative exponent, then it goes upstairs and it becomes a positive exponent. Okay, pretend like this is over 1. This is not in your book right there. This one here is also not in your book. If you have a fraction to a negative exponent, flip the fraction, it becomes a positive exponent. Okay, that one's especially slick. Okay, evaluate the expression. Okay, quantity, negative 3 squared, only the 3 is being squared, times 5 equals, times 5, and then all to the 3 power. Okay, first, you guys, I'm going to do, notice this, negative 3 squared is not the same as quantity negative 3 squared. This quantity, negative 3 squared, is negative 3 times negative 3 that many times, which is positive 9. This negative 3 squared is saying negative 3 squared. So 3 squared is 9, so this is negative 9. So this is negative 9. Okay, negative 9 times 5 is negative 45, so I get negative 45 cubed, which is negative 45 times itself 3 times, which is whenever you have an odd amount of negatives being multiplied is a negative, so negative 91,125. Okay, did that in my head? No, I didn't. Alright, so here, there's about 4 correct ways to do this. So students will come up to me and say, Mr. Bullock, I did it a different way and I got the correct answer. And I'm going to say you probably did it correct because there's several ways to do this. For me, for right now, I'm going to do powers to powers. 4 to the negative 2 is negative, 1 to the 4th to the negative 2, I'm going to multiply those powers. 4 times negative 2 is negative 8. Similarly, 3 squared to the negative 2, I'm going to multiply those and get 3 to the negative 4 power. Alright, now 1 to any power is 1. 1 to the cajillion power is 1, you guys. So 1 to the negative 8 is also 1. I don't need to deal with that power. I could have done that right here and just left that 1. Okay, 3 to the negative 4 right here is going to become 3 to the positive 4, because 3 to the negative 4 is in the denominator, so I put it in the numerator and made it positive 4, and 3 to the 4th is 81. Okay, let's go ahead and simplify some expressions here. All right, here I have c to over c to the negative 4, and all that's being raised to the negative 3. Pretend like there's a little 1 right there, an imaginary 1. C to the 1 be to the negative 3. I'm going to powers to powers and multiply them and get c to the negative 3. And here I had negative 4 times negative 3 is a positive 12. All right, and then I'm going to flip this, throw this downstairs, and it becomes a positive c to the positive 3rd. Now when there's nothing left upstairs, it's always 1. Okay, so don't lose that. And so I get 1 over c cubed times c to the 12th. I add those exponents, so it's 1 over c to the 15th. Now, unless otherwise specified, you guys always leave answers with positive exponents only. So 1 over c to the positive 15. All right? Okay, so don't make it c to the negative 15. Make them always positive exponents. Okay, number 2. All right, on this one here, what I did first here is I added these exponents. Negative 3 plus 5 is 2. So I just, since this is x and this is x, I just added these exponents. That's all I did right there is I added those exponents. Okay. Now I'm going to throw this upstairs right there. So this y to the negative 2 is going to go upstairs and become y to the positive 2. Can you see that? It went upstairs. I changed them both red right there. Now I'm going to go ahead and go, I have y squared. Y squared is going to be y to the fourth because I add those exponents. All right, and then what I like to think of is 2x's upstairs are going to take away 2 of the 4 downstairs, so there's 2 left. So you have y to the fourth over x squared. All right, okay, this one here. First thing I did is I went ahead and cross-canceled. 3 goes into 6 2 times, all right? And then now I'm going to flip all those negative exponents right there. So this y to the negative 2, I changed it to be red, and it became this guy, y to the positive 2. And similarly, I changed this to blue. X to the negative 4 went upstairs and became x to the positive 4. Now I'm going to go ahead and add these exponents. X cubed times x to the fourth becomes x to the 7th. You guys with me? And similarly, y squared times y squared is y to the fourth because I added those exponents. Now, it's just like I did right here. I have 3 y's upstairs, going to take away 3 of the 4 downstairs, so there's 1 left. Okay, so 2x to the 7th over y. All right, scientific notation is of the form c times 10 to the n. C is some number that's between 1 and 10. It could be 1, but it can't be 10. It has to be less than 10. And n is an integer. An integer is like 1, 2, 3, 4, 5, or 0 is an integer, and -1, -2, -3, those are all integers, dot, dot, dot. All right, so let's see. Write the answers in scientific notation. Here's number 1. Okay, 5.2 times 10 to the third times 1.3 times 10 to the fifth. Okay, what I'm going to do is put these numbers together and put the tens to the powers together. All right, so what I did is I combined those and I went ahead and multiplied 5.2 times 1.3. Here I just add these exponents because this base to the power, this base to a different power, I just add the exponents, so 3 plus 5 is 10 to the 8th. Okay, and 5.2 times 1.3 is 6.76. 6.76 is between 1 and 10, so I'm good. That's my answer. Okay, here's this one. I'm going to do the same thing. Set those up. 8.3 times 4.2 is 30 something, 34.86, okay? And I added these exponents. 5 plus -2 is 3. Now 34.86 is bigger than 10. I want it to be less than 10, you guys. So to make it less than 10, what I'm going to do is throw this decimal to the left 1. And when I throw that to the left 1, it increases this exponent over here times 1. Okay, because this is just a power of 10 when I go to the left right here. So it's just going to make this a bigger power right here. If I went to the left, you know, say 2 spots, and I'd increase that by 2. So however many times you move it to the left, that's how many times you increase your 10 exponent. So this becomes 3.486 times 10 to the fourth. All right, one more, you guys. Let's do a division 1 here. Okay, here I'm going to combine the numbers and combine the tens with each other. Okay, this is 1.1 divided by 5.4. Here I'm going to go ahead and subtract these exponents right here. Okay, so this is not between 1 and 10, so I'm going to have to move this to the right 1 spot. But let's take care of this here. So when I subtract this, -3 minus a -9 is -3 plus 9, which is 6. Okay, -3 plus 9 is 6. All right, now I'm going to move it to the right this time. When I move it to the right, it decreases that exponent 1, so it's going to be 2.037 times 10 to the fifth. Alrighty, all right, so moving the decimal to the left, you add. Moving the decimal to the right, you subtract. All right, and if you're in my Algebra 2 class, I would assign that to you guys. Take care.